In this video, we're going to see how memory is allocated for functions for local variables and how to examine that memory using the examine command. We're going to set a breakpoint into main, we're going to run the program, and we're going to step over all the input routines asking us for input. And get right to the beginning where we're about to call procedure fib. So let's look at what's happening right here at procedure fib. We're going to look at the stack pointer. We're going to walk through a particular function call. The first thing that's been pushed onto the stack pointer is the contents of EAX. Let's actually take a look at what EAX is. EAX is 3. That was the value of the item that we had inputted. So that's the argument to fib. That was actually retrieved here from -8 EBP EAX. So this came from arguments and return values being passed in to the scanf routine. So we're about to call procedure fib, which is at this address. We've pushed in the argument to this. Let's take a look at what the current stack pointer is. So the stack pointer ends in 550. We're now going to take one single instruction and step, and now let's take a look at the end of the stack pointer. So this is a difference of 4, and that's happened because of the call routine. If we take a look at what's at the stack pointer, we see an address, which is the address for the instructions immediately following the call routine, just as before. We're also now about to push the old EBP on the stack. That's the EBP. As we execute this instruction, it has been pushed on the stack. So if we now take a look at the stack, we'll see that the EBP has been pushed onto the stack. We're now going to copy the current value of the stack pointer to the EBP. And that's exactly what happened. And now we're going to subtract. So if we take a look at the stack pointer, it should be exactly the same. Now we're going to subtract the value of hexadecimal 18 off of the stack pointer. And that's what happened. Now let's take a look using the examine command to look at the layout of the stack. The first thing we're going to do is we're going to look at the first 4 or 5 hexadecimal numbers starting at EBP. The thing that is at EBP itself, so this is the thing at EBP, and then this is at the word above EBP, or the address of EBP. This is the word above that, this is the word above that, and this is the word above that. This is the old value of EBP. That's what we had up here. That's the value that was pushed. This is the return address. If we remember back from where we had come, if we take a look at the code there was a return address that's there. And this is the argument to the fib function right here. So this is the layout relative to the EBP of the arguments in this procedure record. This is the old EBP, the return address, and then this is the argument or the function value being passed into fib. Now if we take a look at starting from the stack pointer, we're going to need about at least, let's say, 10 hexadecimal numbers to look at things from where the stack pointer is. We're going to see the same data because in fact the stack pointer is just under where the EBP is. This is the old EBP. It's the same as there. The return address for the procedure and the arguments. These values through here are all currently unused. This is space between the stack pointer, where the stack pointer is, and where the EBP is, that can be used for temporary variables for the procedure that's being called, in this case procedure fib. If we disassemble the routine here, we see that these variables are actually being used for example, right here. We're going to be saving some registers, the EBX and the ESI registers, into values that are below the EBP, between the EBP and the stack pointer. The data between the EBP and the stack pointer, those with a negative offset, are variables that are local to this given procedure. Later we'll talk about why this is being done, but it's more or less to save the values of these registers across this procedure call. If we then take a look towards the end of the procedure, what we see happening here is code that undoes what happened when we entered the procedure. Here we restore the values from the stack into EBX and ESI, we move the old value of EBP to where the stack pointer is, pop off the old value of EBP, and then return to where the return address is. So that just unwinds the procedure call and makes us go back to the return for that. We're not going to demonstrate that in this particular example. The things to be able to take from this example, you can use the X command to look at information relative to a register. You can format it in many different ways. For example, half-word hexadecimal numbers. You can look at data as strings, even data that doesn't make sense to look at as strings. You can look at it as characters. You can look at it in many different formats. This is useful when trying to understand what the arguments to a function are, what the data that's being provided to the function. Another thing to be able to look at is that functions have patterns to the way that addresses are actually being done. Values that begin with BF, like this, are part of what's called the stack segment. Values that begin with 08, like this, are typically code, locations in the code. Other values, like this, are obviously numbers. So even without knowing what this is, it's likely that this is actually the address of a function of some kind, or some code. So if we copy and paste this code into our window, we can examine and see that that's part of a routine called a init. And a init is the thing that calls main. If we copy this thing here, we see that that's actually part of procedure main. If we look where we are right now, we see that fib is called by main. We don't see any mention of procedure init. That's just a convenience that GDB actually have. Procedure init was actually called by wherever this code came from. Which is something called libc CSU init plus 25. So these are part of the init routine, and the live CSU are part of the setup code that the system puts in to start calling your function main for that. You can use GDB to find these sorts of things out.